Okay, take a look at this. This is a classic. You get a simple little equation and then, bam, they ask for the fourth power. Now your first instinct might be to try and figure out what a is. Don't do it. That's a trap. And under exam pressure, it's just a massive waste of time.
I mean, that looks like it's going to take a while, right? A bunch of steps, lots of room for error. But what if I told you there's a way to get the answer in less than 5 seconds with almost no heavy calculation? And the secret? Well, it's not about being some kind of math genius. It's just about knowing the shortcuts. There are a few, let's call them magic formulas, that turn these problems into a total piece of cake.
So let's get right to it. At the heart of this whole strategy, there are 3 basic formulas you just need to commit to memory. Think of these as the keys to the kingdom of speed, that is.
First up, the square formula. This is your bread and butter. If you know what x plus 1 over x is, then finding the square is so easy, you just square that value and subtract 2. This a squared minus 2 rule is the most important one we're going to use. And no, it's not actually magic, it just comes from expanding binomials, but who has time for that in an exam? All you need to remember is a squared minus 2.
All right, next is the cube formula. Same idea. To get the third power, you take your value a, you cube it, and then you subtract 3 times a. Again, it's simple, it's direct, and it is incredibly fast.
And our third key is what I call the sign flip formula. Sometimes a problem will give you the plus version, but you actually need the minus version. This little trick lets you switch between them instantly. It's just the square root of a squared minus 4. Super handy.
And I want you to really let this sink in. Yeah, you could derive all of these formulas from scratch, but you absolutely do not have time for that when the clock is ticking. The real key to being fast is to have these locked and loaded in your memory.
Now this is where it gets really powerful. That first formula, the a squared minus 2 one, it's not just for going from power 1 to power 2. It works anytime you double the power. This subtitle here, pao ek do, it's a principle that basically means get 2 for the price of 1. It is the art of doubling, and trust me, it's a game changer. Look at this slide, it shows the idea perfectly. On the left, we're going from a half power, a square root, to a full power. On the right, we're going from a full power to a double power. See? The logic is exactly the same. If the power doubles, you square the value and subtract 2. It's a universal rule.
So let's go all the way back to that first problem we saw. We want the fourth power. All we have to do is use the doubling rule twice. Okay, first, we take our starting value, 3. 3 squared is 9, minus 2 is 7. That's the value for the second power. Now we just do it again. Take that 7. 7 squared is 49, minus 2 is 47. And that's it. That's our answer. Simple as that.
Okay, but you know that test makers, they like to be tricky. They'll often disguise these problems so they don't look like x plus 1 over x right away. The trick is learning how to spot the pattern and, unmask the real problem.
So check this out. We have an x here, but an x minus 2 down in the denominator. They don't match, so we need to make them match. It's easy. We just subtract 2 from both sides of the equation. Now the left side is x minus 2 plus 1 over x minus 2, and the right side is 6. And look at that, the pattern is revealed. It's in our format. So we just apply the square formula to our new value 6. 6 squared is 36, minus 2 gives us 34. Done.
So we've nailed the second and fourth powers, but what about the bigger ones, like the fifth or the sixth? Well, the good news is you don't really have to learn any new formulas. You just have to be clever and combine the ones we already know.
Think of it like this. To get the fifth power, you combine the second and third powers. First, you'll find the value for the square and find the value for the cube. Then you multiply those two results together. And here's the crucial bit, you subtract the original value you started with. It's like building with Legos. You're just using the smaller pieces to build something bigger.
Now, for the sixth power, you actually get a choice. You can either find the square first and then apply the cube formula to that result, or you can find the cube first and apply the square formula to that result. Depending on the numbers, one way might be way easier to calculate, so always be flexible and look for the path of least resistance.
All right, there is one last twist we have to cover. What happens if the problem starts with x minus 1 over x instead of a plus? Well, the formulas are almost the same, but there's one critical difference you have to watch out for. The signs?
Let's just put these side by side. On the left, our original formula starting with a plus. On the right, the formulas for when you start with a minus. The key thing to notice? For the square, you now add 2, and for the cube, you add 3b. It's a tiny change, but getting the sign flip right is absolutely everything. It changes the entire answer. So let's wrap it up. This is your new algebra toolkit. You've mastered the 3 core formulas. You've got the doubling rule as your superpower. You know how to look for hidden patterns, how to build bigger powers from smaller ones, and crucially, you know to always, always check that starting sign. That's the whole system. With these tools, a whole category of algebra problems that used to look really intimidating are suddenly pretty straightforward. The confidence you get from mastering this is a huge advantage. So, you've got the keys. The only question left is, what problem are you going to unlock next?